So hopefully you have already answered all of these questions before starting this video. If you haven't, go ahead and pause here and go through these questions and answer on your own. So this first question is asking you to draw an atom, and here I give you the element as you would see it on the periodic table of elements. We have the atomic number and the atomic mass. Now you know the atomic number is 5 because the atomic number will always be the smallest number. So before you even start drawing, you should figure out how many protons, neutrons, and electrons there are. So the number of protons is 5, and I apologize for this crappy handwriting, I'm just using my mouse, because that's what the atomic number is, and the atomic number is the number of protons. The number of neutrons is 6, and the way I got that is I looked at the atomic mass. Now, if I give it to you in decimal form, you can go ahead and round that. So you can round 10.8 to 11. The atomic mass is protons plus neutrons. So if I do 11 minus 5 protons, that leaves me with 6 neutrons. Now, this is not an ion. If it was an ion, you'd see a plus sign or a minus sign. This means there is no charge to it. This atom is neutral. So we know if it's going to be neutral, then the number of electrons must equal the number of protons. So 5. So we have 5 positives, and now we have 5 negatives. So now we need to draw this. So here's our nucleus. You can just do P equals 5, and N equals 6. Then I'm going to draw my first electron ring. And the first electron ring can only hold 2. That is a 2, not a 1. Which leaves 3 left over. That's going to go in the second one. Now the second electron ring can hold up to 8, but we only have 3, and you would draw it just like that. Now make sure you read these questions fully, because you don't want to miss points because you didn't answer part of the question. I've noticed that on some of y'all's lab quizzes and your previous test. So next question is, how many valence electrons does it have? The answer to this is 3. Remember, valence electrons are the number of electrons on the outermost shell. So we have 2 in the innermost and 3 in the outermost. The final question is, would this element form covalent or ionic bonds? So now you have to remember, why would an element do any of these bonds? Remember, ionic is either gaining or losing an electron, whereas covalent is sharing. Now, losing and gaining electrons is really hard to do. So recall, with bonding, we're trying to get to 8 electrons in the outermost shell. Or, if you're only talking about the first shell, just staying at that 2 in the first shell. So for boron to reach the octet rule, it would either need to lose 3 electrons, it could gain 5 electrons, or it can share electrons with another atom. Now, as I just mentioned, losing and gaining electrons, so not sharing electrons, is actually really hard to do. It's going to be very, very difficult for boron to gain 5 electrons, or it's going to be really difficult to lose 3 electrons. So the answer is not ionic. Boron would form covalent bonds. It needs to share with another atom in order to fill up its outermost shell. So the rule of thumb for ionic bonds is if it has 1 or 7 valence electrons, then it would form an ionic bond. It either needs to lose 1 electron or gain 1 electron. Losing or gaining 1 electron, pretty easy. Losing 3 or gaining 5, really, really difficult. So the next question was a half-life question. So the first thing you need to determine is how much iodine, which is the radioisotope, was originally in those deer bones. So we know right now we have 20 grams. We also know we have 60 grams of xenon. Now this xenon used to be iodine at one point, but then iodine broke down. So you would take this 60 grams plus this 20 grams, and that gets you 80 grams. So that's how much iodine was originally in this sample. So the way I recommend figuring out how many half-lives and how old the bones are is just drawing it out. So we originally had 80 grams. One half-life occurred. So now we have 40 grams. Remember, a half-life is the length of time it takes for a sample to break down in half. So in the case of iodine, it takes 8 days for this sample of 80 to break down into 40. Well, we're trying to get to 20 and we're not there yet, so I'm going to do one more half-life. And now we are at 20 grams. Now the question asks how many half-lives has iodine-131 gone? And so you would answer 2. We went through 2 half-lives. The second part of this question asks how old are these bones? Well, we would just count up the number of half-lives, which is 2, and multiply that by a half-life of 8. So if we do 2 times 8, that equals 16 days. So there you go, 16 days. Now, if you're going to forget, oh, I need to multiply or anything like that, you can always look back at your drawing. You can say, okay, going from 80 to 40, this was 8 days. And 40 to 20, this is 8 days. And you can add them up this way. Now, finally, is a nutrition question. So it asks, of the 2 muffins you ate, what percentage of the calories came from fat? So the first thing we need to figure out is how many calories really just came from everything. Now, just because it tells me right here that there's 250 calories in this, go ahead and recalculate everything, because an actual nutrition label is calculated slightly differently than the label or than the nutrition rules that we learned. So let's figure out fat. So fat has 12 grams. Now I'm going to times this by 2, and hopefully you guys caught that. I said that I eat 2 muffins, but look at the serving size on this label. 1 serving size is 1 muffin. So all of these labels and all of this nutrition information is for just 1 muffin, but I'm curious about 2 muffins. So I'm doing 12 times 2 to get 24 grams of fat, and we're going to multiply that by 9. Remember, there's 9 calories per gram of fat. Now, using my calculator and not a phone, I'm going to calculate 24 times 9, which equals 216 calories. So we got 216 calories, which answers the first question. The first question asked, how many number of calories did we get from fat? 216. The next question asks what percentage of the calories came from fat. So I need to figure out what are the total calories when I eat 2 muffins. Well, I figured out the first part. I know how much is from fat. So I need to figure out how much is from carbohydrates and from protein. So our total carbohydrates are 31. We're going to multiply that by 2 because we had 2 muffins to get 62. Times this by 4. And using my calculator, I get 248. Then I'm going to look at protein. So here's protein. We have 5 grams of protein. Times that by 2 for 2 muffins, which equals 10. Times that by 4 because there's 4 calories per gram. That gets us 40. So now we know how many calories came from carbohydrates, from proteins, and from fat. So the total number of calories, if we eat 2 muffins, we just add all of these up. So I'm going to do 216 plus 248 plus 40 to get 504. Alright, so we have 504 total calories. The question asks what percentage of that 504 calories came from fat. So the way to figure this out is how we did it in lab and in class. Take 216, which is the calories from fat, and divide that by 504. That's going to get you a decimal, and to turn that into a percentage, you would just times that by 100. So I'm going to do 216 divided by 504. That gets me 42.9. I'm just rounding. So 42.9%. So the final question asks, is this higher or lower than recommended? Now remember, what's recommended is 30%. The max number of calories that you should be getting from fat in any food you eat is 30%. And this is a lot higher. This is nearly 43%. So the answer to that last question was this is higher than the recommended amount. So those were all of the practice questions that I had. But if you have any questions at any point, please send me an email just before the test. The test is on Tuesday morning, so try to send in your questions before, say, Monday evening. Good luck!